Hi, everyone. Let's take a good look at absolute value equations and inequalities. They can be a little tricky, so you want to understand the meaning, first of all. Okay? So equations will obviously deal with an equal sign at all times. That's what makes it an equation. Absolute value will deal with absolute value bars. You'll see those always. Without those, you don't have an absolute value indicator. So what does it actually mean? An absolute value is nothing but a distance from zero. So let's say you have the absolute value of -5. What's that? Well, that's 5 steps away from zero. Those steps can be looked at as a positive distance. So that's why the absolute value of -5 will also be +5. And the absolute value of 5 will equally be 5. So what does that give us? Okay, what that does is you end up with a disjunction if you graph it. What does that mean? You have two unique values that do not overlap. Okay, you may have in that particular example I was talking about 5 and -5 as your answer because they're both equidistant from the point 0 on the number line. Okay, so unique values must be a disjunction, no overlap, no intersection at that point. So in general, you have the absolute value of x equals a. What does it mean to drop the absolute value bars? You're going to keep 1 as is and just say x equals a. And then you're going to turn the other one to its opposite and say x equals -a. And it either is this or that. So let's look at example number 1 with an or situation as well. So example 1 shows you the absolute value of x minus 7 is equal to 5. You have to understand with equations, the left side must have the same value as the right side. So whatever it says on the left side, better equals 5. Okay, so that's really what it tells you. Let's go to the editable one. And that is what it tells you. When does it happen? I have to drop my absolute value bars. So 1, I'll keep as is. Okay, this first one is kept as is. And I just drop the absolute value bars. X minus 7 equals 5. Solve for x. And you get x is 12. Okay, here we go. X is 12. And then the other one, you keep the left side equals, and you change the right side to its opposite. Okay, in order to drop the absolute value bars, in order for these guys to go away, you have to change the outcome to its opposite and see what happens. Now, let's just make sense of it. If I plug in 12 for x, 12 minus 7 is 5. So that is correct. Always check, guys. If I plug in 2 for x, what happens? I would get 2 minus 7 is -5. And we just said the absolute value of -5 is 5, since it's a distance, number of steps away from 0. So it still is correct. So you have two unique values that satisfy the equation of this absolute value situation. Now let's look at the second example. Now you have something going on in addition to just the absolute value bars. Okay, and because of that, this buddy has to move away. So you do -5 first on both sides. You have to isolate first. Okay, so on -5 on both sides, you isolate your absolute value and you go from there. Okay, so what happens? I keep 1 as is, drop the absolute value bars, and I change the other one to its opposite. That's it. Next example. Notice, this time you're looking at inequalities. Either greater than or equal to, or less than or equal to. Now, to help you think, I thought about, okay, greater sounds like greater. So anytime you have that greater than symbol, you will be thinking of greater. That will be a disjunction. That's your indicator. That's your hint. A disjunction, once again, goes in two different directions, no overlap when you shade. By the way, now it's not a one unique value. It is a shaded area because you're working with inequalities. So what if you have less than inequalities? Okay, the less than inequalities are conjunctions, which means now you have an intersection where you shade in between. Okay, so summary. Or results in a disjunction, and we know that when we see this, greater than or equal. And means a conjunction, and we know that and we have that when we're dealing with less than or equal to. That's it. Now let's look at examples. You will be given an example, but first you want to predict, is it a disjunction or conjunction? So let's investigate the inequality that is given. What is given? Greater than. Greater is indicative of greater. So I already know, as I set up my absolute value stuff, I know that one side, whatever it may be, and I put or, and I put the other side. So one side I keep as is, as long as there's nothing going on. Like if you had another, whatever, 3 here and a -2 here, you would have to do stuff. You would have to move this stuff away and isolate your absolute value expression. It's already isolated on the left, so now I can continue. Now, anytime you do the or, now you're switching the inequality as well as the number. Hear me say that. You are switching the inequality sign as well as the number. Now you solve again, same procedure. Now you are looking at what are my two types of notations that we have primarily discussed in addition to a couple other things, but set builder notation and interval notation. That's what you're looking at. The first one here with the U is the set builder notation. Anytime you use inequalities to describe what you're about to say, like this is called set builder notation. Now that we've done this, let's look at a different example that shows a conjunction this time. How do we know that? We have a less than or less than equal to situation, and we do. And once you've identified it, you're going to put the word and in between. Okay, so let's do that. This guy right here, and then you're going to put the word and. And you expect an overlap in shading. Unless there's no solution, there's an exception, and I have that for you as an example. So here you go. What is happening? You keep isolate your absolute value, then solve. Keep one as is and change one where you change the inequality symbol as well as your number to its opposite. And then you solve it. Do the set builder notation, which tells you x is greater than or equal to -5. And it's at this point greater than, less than or equal to 11. There you go. One more example, and it's the last example. You decide, is it a disjunction or conjunction just by looking at it? And then you can take a look at the steps to make sure that you understand. This one is different because while it looks like, hey, I did everything, right? I switched, I did everything. But only the graph will tell you how to actually state your final solution and whether or not you can write it in interval notation or set builder notation so that it makes sense. Now think about it. Can a number be less than or equal to -5 and because it was less than, right? Less than. So this is an and situation. And at the same time, greater than or equal to -1. Now, when you do the little sketch like I did here, you will notice that it's kind of hard to be that at the same time. Okay, you either or, but you're not and. So again, those can be a little tricky. You will have to take your time and practice. There's plenty of practice available for you. Have fun with it.